Hello everybody, this is Della from The Beauty of Play. For our astronomy block, we did quite a few illustrations that help us understand the concepts within our astronomy block. And one of them that we did was the polar constellations for the North Star. To begin this illustration, I am finding roughly the center mark of our paper and drawing the largest circle that my compass and the paper allows to cover most of the paper. My goal here is to draw the celestial coordinate system that we learned about in the previous illustration, and then use that grid to draw the constellations in the polar north. There are a variety of different compasses that can be used. In this particular one, I'm using our compass that holds a pencil. The reason that I'm doing that is because I'm looking for contrast against that dark background that the lead doesn't offer. So I've placed in either a chalk or a contrasting pencil to draw this circle. The materials that I am using are the black cardstock, which we've used quite a bit for the astronomy block because we're mimicking the night sky and it provides a nice contrast between the dark and the light. And then I'm also using chalk pencils by Faber-Castell, which are okay. The lighter colors thankfully worked really well, and that's what we were using the most of for the contrast. The darker colors, we had significant time sharpening those. They did not work really well. They crumbled before they sharpened. Regardless of what we seemed to use, we could not get them to hold up. But given that we didn't use them very often, that wasn't a problem for us. I'm also using the Prismacolor chalk pastels for this work, and they are my preferred pastel chalks. We also use these for our chalkboard drawing. This part of the construction is really unnecessary, but I really enjoy the artistic aspect of it. And what I'm doing here is taking some purples and some blues and making a little background before I draw the coordinate system and label the stars within it. We are definitely using a reference photo for this illustration, and that is from the polar star map from DK's universe. This worked really well for us because it has most of the lines of right ascension and declination already labeled. A quick reminder of how the celestial coordinate system works, because it's something I certainly needed. It works similar to latitude and longitude, imaginary lines on the earth that provide a coordinate system so that we can graph or pinpoint where a certain location is. This works the same, only projected into the sky. Longitudinal lines would be our lines of right ascension that go up and down from north to south in the earth, and those are projected into the sky. And the lines of declination mimic the latitude lines that we have on the earth projected out from the earth into space, which provides a coordinate system in the night sky where we can locate various stars and constellations and planets. After I finish my artistic background for the night sky in this construction, we start constructing our celestial system, that coordinate system, onto our drawing. We do this by dividing our circle into 24. If you have worked with Waldorf geometry, this division of circle and compass work will be really familiar to you. One of the differences in the coordinate systems is that though latitude is measured in degree and minutes, the lines of right ascension are measured in hours, in the same way that our Earth rotates in 24 hours. For that reason, this circle will be divided into 24. We begin that division by bisecting the circle through the center and a point on the top of the circle. After the circle is bisected, we're going to do a division of 6, which in my opinion is the easiest division to do. Leaving the measurement of the circumference is the same as it was to draw the original circle from the center to the outside of the circle. We are going to put the compass on each endpoint of that bisection and find 6 points that are equidistant to divide the circle. We're going to continue to divide the circle by drawing a line through those points through the center to the other side of the circle, and this will give us a division of 6. Our next step would be to divide each of those angles and draw 6 additional bisecting lines that would divide our circle into 12. If we're doing this with precision, we would use our compass and straight edge to divide each one of those angles precisely and find the midpoint. Here you can see I am bypassing that step and really eyeballing this to dissect each one of those angles and draw the bisecting lines that now divide our circle into 12. By dividing each of those 12 sections in half again, we have our division of 24. Again, to do this precisely, we would bisect an angle using a compass and a straight edge to find the division and draw the bisecting lines. But I am not being precise here and just simply eyeballing it and dividing each one of our 12 sections so that we have a division of 24. At this point we begin to label our lines of right ascension. It doesn't really matter where you start, with the exception that it changes the perspective of your drawing. To make it simple for us, we labeled the lines of right ascension according to the diagram that we were looking at in DK's universe. Essentially what this did was just make it easier for us to graph the stars according to that illustration. These are labeled 0 to 23 hours. Just to know, our reference photo that we were using in the book DK Universe of the Polar Star Map did not have all of the lines of right ascension labeled. I actually filled those in the book so it would make our replication of that illustration a little easier, and also when we went to transfer the stars and graph them, that we would be able to see what segment they were in because it was clearly labeled. At this point, we are putting in our lines of declination, and this is just a series of concentric circles. The way that we did that is to measure that entire line that fit and then do a series of halves, so that we have 4 lines of declinations for our coordinate system that we are placing in our illustration. If I am remembering correctly, I think the radius of our circle was 4 inches, and so we just divided that 4 by 4, giving 1-inch concentric circles. So this circle that I'm drawing here is a 3-inch circle. Then we are moving into a 2-inch circle and a 1-inch circle. And these are giving us a series of concentric circles, which are our lines of declination. The lines of declination correspond to the latitude lines on the global positioning system. Notice after I have the circles drawn, I'm going back with another pencil and darkening up those lines so that our coordinate system is a little easier to see. This is the point where we start to graph in our stars and constellations. The different stars have different luminosities, meaning that we see them at different brightnesses in the sky, and we are trying to use some demarcation to illustrate how bright the stars are and if they're particular stars which we label. This illustration serves a couple different functions. It does enhance our understanding of polar stars and where they are in the coordinate system, but in previous illustrations and study, we have worked with the celestial coordinate system. This allows us to review how that works. It also allows us to use the information that we've previously learned on the coordinate system in this illustration. In addition to that, we have already been talking about studying different polar constellations within the unit, and this gives us the opportunity to see where they fall in our coordinate system and to review the information that we learn about those polar constellations. The first constellation that I started with here is Draco, and Draco is a larger polar constellation, the dragon, which has quite a long tail, so we are hitting a lot of different quadrants within our little coordinate system. Most of the stars I am drawing in white, and then I am also using a red, yellow, and sometimes blue color to depict the different kinds of stars, which are also depicted in the illustration that we are using. This also backs up the information that we are learning about stars, about color, luminosity, distance, etc. Some of these illustrations she is doing on her own. Many of the illustrations I'm using as a teaching tool to teach a lesson and to review the material that we've gone over in the past. This illustration definitely falls into a teaching tool where we are reviewing the coordinate system, we are reviewing the constellations, we are reviewing the information that we're learning about stars in general. After we have all the stars drawn for the constellation of Draco, we are going back in and connecting the lines that form the constellation. There's no particular order that this needs to be done in, but to keep things organized and to make sure that I didn't miss any of the constellations in the north sky, I went through in a clockwise direction and filled in the rest of the constellations. This was done in the same way that we did Draco, with marking the different stars first and then going back in and connecting those stars with lines and labeling the constellation. The wonderful thing about this illustration in particular is that it also serves as a map for us with the stars in the north sky. We can go out with some red lights and our star map and take a look at the north stars and notice where each of them are, go out later during the night and notice where they shift and move throughout the evening. You can also do this seasonally. In fact, that's probably ideal, of going during the night, taking a look at the northern stars or all the stars, where they're located, the constellations, how quickly they move through the sky and in what direction, and then go out in a different season and see how that constellation shifts, not only through time during the evening, but also time through the seasons. And that's it for this illustration. I hope it was useful. Feel free to leave any questions below and look for more details on my blog at thebeautyofplay.com for the full episode and more information on our astronomy block. Like and subscribe if you would like to see more videos, and feel free to share with a friend. This particular astronomy block was very heavy on illustrations, and I hope to share more of those illustrations in the future, so follow along to see those.